Hello, in this video, as you know, we will be translating our algorithm that we did in the last video into code. And so before we begin writing the code, there's a few things that you need to download. The first one is Atom, and so what you have to do to download Atom is just go to Safari and search atom.io, and so you can download it for Windows, Linux, and Mac. Just click download, follow the process, and come back here. Alright. And so we'll go to a black hole algorithm. And so it says ask what the 6 numbers are for the background interference and set as a variable. So there's going to be 6 variables. So I'm going to say first number is equal to float. If you know what float is, because I'm writing an input statement, so I'm writing input, and so you need float because input is going to be a string, so we're going to do math with the input, and you can't do math with a string. It's like saying a plus b, you can't do it, so you need to convert it into a number. So you say float enter, oh I spelled it wrong, enter number, then second number is equal to float input and you keep doing that until you reach the 5th number. I'm gonna copy and paste it because I already did it, but you can keep doing it. Okay, 3rd, 4th, 5th, okay? 5th number. And so the next part of our algorithm is that you get the average of these 6 numbers. So you say first base num is equal to first number plus second number plus third number plus fourth number plus fifth number, and let's see, yeah, you divide this by 5, so you go out of the parentheses since you're doing all this first. Alright, and then the next part is asking what the peak is. So you say peak is equal to the int is an integer, input enter peak. So in case you didn't know, I'm writing this in Python, but you can write this in any language, but you have to learn Python first since Python is an easy language. It's very flexible, very powerful. It can do a lot of computation in half a second. So once we write peak, you enter the peak. We have to copy this one, but different variables. So I did it here. I named it first number 1, float input, enter number, and so just copy this, put it here. So we're entering numbers, and then we calculate the second baseline, because in our algorithm we say get the average again. So we get the average first. I'll tell you what CAD stands for. So we get the average, and we store it in a variable. It's in a variable. And then here we have CAD, float, input, enter calibrator, assume flux. So calibrator, assume flux is basically, how do I explain it? It's what the telescope thinks is the difference between the black hole and the object. So they get a lot of data and they see the average between it, and they put that as the enter calibrator assumed flux. So it can be really helpful sometimes, but most of the time it's not really that helpful. But it's good to have it in your calculations. Okay, so CAD, float, input, enter calibrator assumed flux. And then once we get through this one, so in our next algorithm, we take the different variable and the new variable and you divide it by 2 and store it as a total val. I didn't store it as a total val, I said average base num because it's a better variable, but you can still store it as a total val. So click enter, you store it, you don't want it there, you want to put it back there. And then you have delta temp is equal to float peak minus average base num. As you know, delta temp is how bright an object is compared to the relative objects around it. And we're doing this in radio waves, and we did that right here. Okay, so our next one is delta temp is equal to float peak minus average base num. No, I don't want that. Alright, so you float it, you do peak minus average base num, and you have all these variables, but the thing is, you don't get anything out of this. This is it. Because you're not doing anything with it. And that's where this comes in. You print everything here. Print average base num, peak, delta temp, flux, target temp, and target temp to JY factor, temp to JY factor, actual temperature of the black hole, and you don't print it normally. So as you can see, we print it as a string here, and we print the variable out. But the problem is with just printing this variable out, Python rounds it, and we want it as accurate as it can possibly be. So what we do is we print, but we tell it that it has to be, the number has to have 15 decimal points after the actual number. So it'll be really accurate. So I'm just gonna copy all of these statements because I don't want to write them again. But go ahead, pause the video, and you can continue writing them. Printing is just, you're printing out a variable or a string or a number. That's it. Printing is when you get the output of the program. All of this is the input of the program, and so this is the output. So all this is the output. So this output is, it helps us because, you know, that's what the program is. Otherwise, you have to see what the variable is. You have to print, you have to write x, you have to write second base num, you have to write average base num, you have to write delta temp. Instead, you could just print it out in a 1 second. So what we're going to do now is we're going to save it. So Control Shift S, or if you're on a Mac, Command Shift S, or File Save. File Save As. Command Shift. I'm doing Command Shift S. Okay. So I'm gonna save it as BHA1, Black Hole Algorithm 1. It's gonna be saved in Documents, and you're gonna click Save. Okay. Now, see, it's not running anything. that's good. So if you want to run it, you have to open something called terminal. New window. So you do ls and desktop. Desktop's right there. So in order to go into desktop, you cd desktop. And you do ls again, which is basically saying list all the things inside your folder. You click allow if this pops up. If you use terminal before, then I'm pretty sure it won't pop up. And ls. Oh no, it's in documents. So I have to close this terminal window again because I messed up. Sorry. Make sure to remember where it is. ls cd documents ls. Okay. So now you see BHA, BHA1, black hole algorithm. So ignore the black hole algorithm, ignore BHA. BHA1 is what we're looking for. So in order to run BHA1, there's many ways based on the language you did it. So if you did Java, you can do javac BHA1, and it usually ends with Java. But see, if I run Java the BHA1, see, okay, just click OK. Yeah, there. I wrote in Python, so there's no class name, so it doesn't really know. If you wrote it in Python, you do Python BHA1. Okay, I'm just gonna enter 37 point This is just testing. These numbers aren't real. Usually the numbers begin with 37 and then with decimal, or they begin with 39. The peak begins with 39. Okay, so I'm going to enter the actual calibrator assumed flux for an object called 3C123. This is a radio galaxy, so it's 9.433. And see, boom, it just prints out everything that you need. Okay, so I do this by hand, and I have a calculator beside me, but just imagine how long it would take to do one of these. For this one, you know what you have to do? You have to take the delta temp, you have to multiply it by the calibrator assumed flux, and you have to get the flux. You have to get, and then once you get this prototype flux, I guess, you have to multiply it by the target temp to JY factor. Then you put it here. But now, since we automated it, it's just half a second and everything's printed out for me. If you have, okay, Python is a very easy language to learn. You can do it in maybe a day. If you're really into it, day. For me, it took a month, mainly because I was going a little bit too deep into it, like really deep into it, like databases, and then you start to get into SQL, and you start to get into Java, you start to get into XML. But for this one, it's just variables, print, input. That's it. That's literally it. And float and int. Yeah, that's it. And basic addition, you know. If you don't know addition, that would be kind of sad, but I'm pretty sure you know addition. If you have a powerful computer in your hand, it's meant to be used. And the only way to use it is to learn a program. So, I can use it in astronomy. You can use it in whatever you want. My cousin, he uses it in gaming. Okay? It's not really a practical use, but he does it. So, astronomy and computing can come together. This is a very basic example. Next time I make another video, I will be doing pulsars, and we will find a pulsar object with a Python program. I'm going to do Python in this channel, but once again, you can use any language you're comfortable with. The closest language I can think of is probably C, because C is like, it's around there, it's around the easy stage. And then, because I use it for Arduino, I don't really know much about it, but it seems okay to me. But Python will be really easy for you. Just follow along, and I'm pretty sure by the end of the channel, you'll know a pretty good chunk of Python.